Hello students, welcome in chapter number 11, 3-dimension geometry. Students, today I continue in the parts of distance from a given point to the given plane. In exercise 11.3, question number 14. 1 point is given 0, 0, 0 and plane given 3x minus 4y plus 12z equal to 3, and I want to find distance from given point to plane. It's very easy, students. Consider that's your point x1, y1, z1. It is 0, 0, 0, and that's your plane, and the distance traveling from the plane, I just want to answer 3x minus 4y plus 12z minus 3, and that's your point A to point M. So very easy. Distance from formula you know. Distance from ax1, y1, z1 to the plane lx plus my plus and z minus d is equal to 0 is this distance. Am distance is modulus lx1 my1 and z1 minus d upon under root l square m square n square, and a value applied at this L, M and N. So my value is, students, very easy, 3x1 minus 4y1 plus 12z1 minus 3 upon 3 square minus 4 square and 12 square. That's your x1, y1, z1. Indirectly 0, 0, 0 minus 3, and that should be your answer is 3 square 9, 4 square 16 and 12 square 144. It is 169. I mean 3 by 13, and that, students, our first questions is very easily and happily this perpendicular distance from A to plane is over. Now continue, students, in question second. In the B, point given and plane also given. My point is 3 minus 2 1 and plane 2x minus y plus 2z plus 3 is equal to 0. 2x minus y plus 2z plus 3 is equal to 0. Similarly going and also draw similar figure. That's a plane. Here your distance A to M. A I have 3 minus 2 1 and 2x minus y plus 2z plus 3 is equal to 0. This statement is same as write down distance from A points x1, y1, z1 to the plane lx plus my plus and z minus d is equal to 0. So that distance is am distance is lx1, my1 and z1 minus d by l square m square same. So value applying 2x1 y1 to z1 upon 2 square minus 1 square and 2 square. Apply x1, y1, z1 value, that 3 minus 2 1. So here 2, x1 is 3, y1 is minus 2, z1 is 1 upon, just calculate the value, 4, 1, 4. So 6 plus 2 plus 2 plus 3 by root 9. 6, 10 and 2, 2 and 10 and 13. 13 by 3. That's your second answer done. Now students, continue question number third. There are the total 4 questions given. In the part C, point is different, line is different, only this I change. Statement same. and that also same as our point is 2 3 minus 5, and plane given 2 3 minus 5, and plane I have x plus 2y minus 2z, x plus 2y minus 2z is equal to 9. So very easy, students. Here also same as derive the drawing. Point write down here 2 3 minus 5, and plane I have x plus 2y minus 2z minus 9, and suggestion same as distance from ax1 y1 z1 to the plane lx my nz minus d, formula same. So x1 plus 2y1 minus 2z1 minus 9 upon, here coefficient is 1 plus 2, and here also minus 2, and start the answer. So it is a x1 y1 z1 is this x1 y1 and z1. X1 is 2, y1 is 3, z1 is a minus 5 minus 9 by 1 4 4, and calculate the answers. So here answer is 2, 3 to the 6 plus 10 minus 9 by root 9. In short, you get the answer here 6, and to 8 and plus 1 9 by 3, which is only and only 3. Now continue another points. Question number D, fourth one, minus 6 0 0, and the plane given same as question, students. This plane are given, and the distance from A is also changed. These are changed, and question is minus 6 0 0 is first, and plane 2x minus 3y plus 6z minus 2 is equal to 0. 2x minus 3y plus 6z minus 2 is equal to 0. Very easy. I write down here minus 6 0 0, which is x1 y1 z1, and plane to the M point 2x minus 3y plus 6z minus 2 is equal to 0. Very simple. Apply distance from A points x1 y1 z1 to the plane lx plus my plus nz minus d is equal to 0 is this formula, and apply on it. 2x1 3y1 6z1 minus 2 by under root L square M square N square means 2 square minus 3 square and 6 square. Apply x1 y1 z1 value, that create, it is minus 6, another is 0, minus 2, and that is your answer, students. 4 9 36, 6 to the 12 minus 2 by 49 9. So it is a purely positive 14 by 7. My answer is only and only 2. Yes, students, here our exercise is over. Now I go to related our examples. Yes, examples, remaining example I will start. So in the last part I explained our example number, yes, up to your 20 example done. So now I go to example number 21, and 21 have one of the conditions, prove that given two lines are coplanar. Yes, here new point is coming. Example 21, to prove lines are coplanar lines. Students, coplanar lines means, yes, lies on the same plane, and the lines given first, L line x plus 3 by minus 3, y minus 1 by 1, z minus 5 by 5, and second line M line x plus 1 by minus 1, y minus 2 by 2 and z minus 5 by 5. Students, first of all I explain you for the basic conditions when the lines are coplanar. So very easy. First of all you just define here a dash and directions L. Here a dash means dash 3 minus 1 5. Secondly, here directions minus 3 1 and 5. Similarly here students B and direction M. Here minus 1 2 and 5. Direction students minus 1 2 and 5. So condition is that if a lines are coplanar, so that is the main conditions. If L and M are both coplanar, then we necessary prove this values is equal to 0, and value is there x2 minus x1, y2 minus y1, z2 minus z1, l1 l2 l3 and m1 m2 m3. Please consider your x1 y1 z1, x2 y2 z2, that is your l1 l2 l3 m1 m2 m3. So I will start from that bottom easily. x2 minus x1, y2 minus y1, z2 minus z1, l1 l2 l3 and m1 m2 m3. Apply the value and prove anyhow. Answer is 0. So x2 minus x1 means that minus 1 minus 3. It means plus 3. 2 minus 1 and 5 minus 5. Now students, L1 L2 L3 means minus 3 1 5 and last minus 1 2 5, and you create your answer. It is 2 1 0 2 1 0. Next of the minus 3 1 5 and last minus 1 2 5, and just calculate by the simple definition of our determinants rule, and anyhow prove this answer is 0. Then our target is achieved. It is your coplanar. So here solution is a 2 minus 1 but last of the 0. Here 5 to 10, last minus 15 and plus 5. So here 2 with minus 5, minus 1 with minus 10, indirectly minus 10 plus 10, but finally answer is 0. So lines L and M are coplanar lines. It means they determined one of the unique plane. Yes students, after that example 21, the 22 and 23 is a cancel part. So now I will go to example 24. Yes, example 24. Students, 22 and 23 is cancelled according to your board syllabus. Find distance from the plane to the plane given r dot 6i minus 3j plus 2k is equal to 4. 6i minus 3j plus 2k is equal to 4 to the point 2 5 minus 3. Very easy. One more time check. 6i minus 3j plus 2k minus 4, and the point is 2 5 minus 3. It's very simple. Students, here you consider your point P 2 5 minus 3, and that's your distance from plane. I want to answer. Here a perpendicular distance, PM distance, and plane is a 6x minus 3y plus 2z minus 4. So I convert given plane in the Cartesian form first. It is considered xi, yj, zk into 6i minus 3j plus 2k is equal to 4. Indirectly 6x minus 3y plus 2z minus 4 is equal to 0. And very easy formula you know. Yes, distance PM already I written in the previous part, so here direct written 6x1 3y1 2z1 minus 4 by under root 6 square minus 3 square 6 square minus 3 square and 2 square. Apply now value. x1 y1 z1 is this, and L square m square n square already I written the coefficient of x y z. So my answer is 6, x1 is 2, y1 is 5, z1 is minus 3, and upon as it is. Here 36, 3 square 9 and 2 square is a 4. Now answer create. So 6 is a 12, next 5 is a 15, minus 6 minus 4 by here 30 and 6 and 40 and 49, which is 7, but upper sides very easy. 6 and 4 10, 10 and 15 25, 12 minus 25 minus 13 means your answer is plus 13, and plus 13 up to is correct answer. Now after that 25 example students cancel, 26 also cancel. So now I will start the example number 27, which is most IMP for exam oriented. Example 27 is the IMP question, sir. Many time asking in the final exam, so you will tick mark in very most IMP numericals. Now students, continue in the example 27. Find the equation of plane through the content passing through 1 minus 1 2 and perpendicular, this is the main line, perpendicular to both plane 1 and plane 2. So I want to plane third which is perpendicular to 1 and to both. It means generally your drawing is this. Consider that's your plane 1, here your plane 3, that is the 3 plane, that is a derived answer, and here I will get to plane 1 and plane 2, that is plane 2 and that is plane 1. Both have the perpendicular on it. So very easy, simple. I just derive first plane 1 normal. Plane 1 is a 2x plus 3y minus 2z minus 5 is equal to 0 normal. N1 is that 2, 3 minus 2. Same as students plane 2. We have to plane 2 x plus 2y minus 3z minus 8, and here normal n2. So 1, 2 minus 3. I want to normal of the plane third, which is n3, but perpendicular to plane 1 and plane 2. It is simple, take the cross product. So normal of required plane which is perpendicular to plane 1 and plane 2 is n 3 directions, easily n1 cross n2. That's the main. Students, in your textbook calculation different method given, that also true, but this is very easy. So n3, what's your normal for the n1 plane? 2, 3 minus 2, and second is similarly 1, 2 minus 3, and then easily I will derive to ijk my determinant calculations. So easily you cover your answer direction of the third plane, I mean n3 plane. So n3 directions which cover to ijk, and here are 2, 3 minus 2, and last 1, 2 minus 3. So it covered to I minus j and last k, and derive third plane directions. So 3 minus 9 plus 4, second minus 6 plus 2, and last 4 minus 3. So minus 5i plus 4j plus 1k. That's your n3, normal of third plane, required plane. Now draw the again drawing. That's your plane which have to normal known you, n3, minus 5, 4, 1, and passing through, given that a, what the passing through here, students, according to data, 1, minus 1, 2, and that you create very simple and easy answer. So required plane having normal n3 which is minus 5i, 4j, 1k, and passing through, what the passing through, a, 1, minus 1, 2. An equation of simple you plane, students, known that r dot n, a dot n, here xi, yj, zk dot n. N is normal, that minus 5i, 4j, 1k is equal to passing through same 1i minus 1j, 2k, and here also same minus 5i, 4j, and 1k. Apply simple dot product between that minus 5x plus 4y plus 1z, and right side similarly here minus 5, next minus 4 and plus 2. So minus 5x plus 4y, 1z is equal to minus 9 plus 2, minus 7. So my plane is ready. 5x minus 4y minus 1z is equal to 7. And here, students, your the equations IMP numericals done here. Now I continue example 28, which is also IMP numerical for board exam related our questions. Example number 28. Derive the plane, and after that asking distance from the given point. Now continue, students, in the example 28, find the distance from the given point 6, 5, 9 to determine the plane by using these 3 points. So first of all, students, I derive my equation of plane. After that I will find out the distance from this plane to the given point P, 6, 5, 9. So first of all, here I point, just consider x1, y1, z1, x2, y2, z2, and last x3, y3, z3. So first I derive equation of plane passing through A, B, C is, you know that formula, x2 minus x1, y2 minus y1, z2 minus z1 is equal to 0. Next, here is, sorry, I written wrong, x minus x1, y minus y1, z minus z1. In second line, x2 minus x1, y2 minus y1, z2 minus z1. Last, x3 minus x1, y3 minus y1, and z3 minus z1. Students, here x, y, z are our variable part plane. This consider values, I just put down there. X minus x1 is a 3, y1 is plus 1, and z minus 2. Continue, x2 minus x1 means this minus this. Here 5 minus 3, same 2 plus 1, same 4 minus 2. And last, x3 minus x1 means minus 1 minus 3, same minus 1 plus 1, and same 6 minus 2. And just calculate, you will get your determined solutions. X minus 3 with first, just I write down again, don't worry. here y plus 1 and z minus 2, and here students your answer to 2 minus 4 3 0 2 and 4, and simple create by the definition of determinate solutions. You will get easily answer. So you cover to answer x minus 3, next minus y plus 1, and last z minus 2 is equal to 0. First calculate 4 3 is 12 minus 0. Now 4 2 is 8 and 4 2 is 8, and lastly students of the 0 plus 4 3 is 12. So my answer is 12 times x minus 3, y plus 1 16 times, and students z minus 2 it will be 12 times. I think overall 4 4 cancel, 4 3s are 4 4s are and 4 3s are. So my answer is a 3x 9, 4y minus 4 and 3z minus 6 and 3z 3 to the 6. Now easily over your answer students, 3x minus 4y plus 3z, and it will be 9 and 6 15, 15 and 4 19. That's your plane derived. Now read question one more time. Find the distance from this P to determine that passing through ABC. So ABC plane ready. So I want to now drawing students, that's your plane. Here your distance from P, given that 6 5 9, and the plane is ready. 3x minus 4y plus 3z minus 19. Distance formula. Yes, now distance from P 6 5 9 to the plane. My plane is a 3x minus 4y plus 3z minus 19 is equal to 0 is PM distance. Apply on it easily distance formula. So 3x1 4y1 3z1 minus 19 by value apply 3 square minus 4 square and 3 square. Apply your x1 y1 z1 6 5 9. So my answer is a 3, here 6, that 5, and here 9. Minus 19 by under root, it is 9, 16 and 9, and easily calculate students my answer. So PM answer is a 6 3 is 18, 4 5 is 20, 9 3 is 27 minus 19 by that will be 9 and 9 18, 18 and 16. Students, it is a 4 34, and upper sides very simple. Here you will get to minus 2, and that will get to your 7 and 8. Yes, it directly 6 total, 6 by root 34. And now students, you will cover to final answer. This is a true, but in your textbook given, just conjugate root 34 by root 34. It is 6 into root 34 by 34. So it is 6, 3 2s are 17 2s are. So 3 into root 32 by 17. That's your textbook answer given, 3 root 34 by 17. And here students, our these questions to distance from given point to determine the plane ABC is easily done. Students, here our I part explain that. It is stop here, and further explanations for example continue in the next video. I will explain students. Bye bye.